Hello, friends. Welcome to Akulmach. My name is Chandrakant, and as you would have noticed that I am live with you across all social media platforms from my command center. And today we are discussing about how a neutron star can mimic a large quasar. So, in this video, in this live stream, we will discuss about quasars and the energy behind these neutron stars and how these neutron stars at times can behave like a quasar. So we'll discuss both the objects. If you have any questions, suggestions, your messages will get displayed on the screen behind me over here, and I can address your question. So without further ado, let's start discussing about what are we talking about today in the science section. Well, the object for our discussion is a X-ray binary, and I will explain to you what is an X-ray binary. But essentially, a binary system where there is a very powerful neutron star, and it is also in that system having a large normal star. And in this X-ray binary, what happens is that the neutron star, being very dense, very powerful object, start affecting the companion normal star and start pulling the material out of the normal star. And as it is doing that, it start basically generating a lot of energy, because now the material is falling into the neutron star, and there is a generation of a accretion disk around the neutron star. And once the material is being pulled towards the neutron star at very high speed, and it is getting absorbed by the neutron star, neutron stars suddenly becomes very powerful. It actually becomes alive, and in such a way that it starts generating all kinds of energies in all kinds of spectrum, and that is what we can see on Earth and observe. So these objects are called binary, X-ray binaries, because they are best visible in the X-ray spectrum, because X-rays are very energetic. X-rays can travel for very long distances, and therefore we can actually observe them back on Earth. However, today we are talking about this particular beast called Hercules X1. And this beast is actually in our own galaxy itself, and scientists have been studying this for many years. This is an X-ray binary. However, there are very peculiar things about Hercules X1, because it is mimicking a large energetic quasars. And even though this object is quite far off, but then scientists have been able to focus their equipment on Hercules X1, and have been able to determine that what is so strange phenomena which is happening on the in this system, where although it is an X-ray binary, it is actually gradually eating its own companion star and emitting lot of energy in all spectrum. However, it is also emanating a huge wave. It is actually giving rise to a huge wave in form of heat, in form of gravity, and it is also creating a lot of winds. And in order to understand this phenomena, the Hercules neutron star is very peculiar, and that is actually helping us to understand what is going on in the star system. So as this neutron star is basically absorbing the material from the companion star, it is actually generating a lot of energy. But there is a very peculiar movement of this particular neutron star, and this peculiar movement is because it is also wobbling. It is not on a fixed orbit, but it is not surprising. Many objects, many planets, like even Earth, has a wobble, because as you know that Earth is inclined at 21 degrees, which wobble between 21 to 23 degrees. And because of this inclination, when it rotates, it has a wobbling period of about 25 to 30,000 years. So This wobbling also creates a lot of weather pattern, which we are understanding, as scientists are basically understanding. So similarly, this neutron star is also having a wobble, and because of this wobble, scientists are able to understand the speed of the winds which are actually coming out from this neutron star. And it is a very surprising fact that the winds are basically so much energetic, has so much power. The energy which is coming out from this neutron star is almost 25% of the speed of light, which is very, very high. Very extremely high speed of the material which is getting thrown out from the accretion disk, and all that calculation is being done using the X-ray telescopes. And since the star has a wobble, we can actually measure, how much wind velocity can be measured in all directions as it is rotating. And this wind is now affecting the nearby space around this X-ray binary. And this peculiar, characteristic of this particular neutron star is very similar to a quasar. So, in nutshell, if you actually approach the Hercules X1 from up close, this is a kind of, and not too close, you don't want to go too close, because then this is a very dangerous environment. But even if you watch it from close by, you may probably see a object like this, not a neutron star, but a very energetic jets coming out from the poles, and a very highly energetic accretion disk, which is actually throwing material and also light and energy in all directions at very high speed. Even the jets which are coming out are nearly moving at the speed of light, and these are basically jets of highly energetic plasma, which has the capability to travel far off distances. Therefore, this is what is happening in this neutron star, which is again very similar to what a quasar will do. And it's very similar. So now this is happening in our own galaxy, in our own backyard. This is very surprising. And how a neutron star start generating so much energy, which is similar to a quasar, was a very surprising fact that scientists stumbled upon. So at this point, let me explain what is a quasar. Well, quasar is an object which is as big as an entire galaxy. Imagine if our own galaxy turns into a quasar, the supermassive black hole in the middle of the galaxy will start getting a lot of input in the form of gas into it, and once a lot of material start to fall into supermassive black hole. And remember, supermassive black hole is really huge. It's a very big body in the middle of the galaxy. It has the capability of getting a lot of material. It can affect a lot of material using the gravity. And as you know, the size of the supermassive black hole in our own galaxy is almost 500 million times the mass of sun. So it's really, really huge object. So once this kind of object start getting this gas, and the gas start to fall in, it gets energized. It's basically start heating up. And as you know that nothing moves in straight line in our space. So as the gas start accumulating around the black hole, it start heating up and moving very, very fast, very rapidly, extremely rapidly. And that is called accretion disk. But in order to form a quasar, the influence of the supermassive black hole in the middle will have to be galaxy wide. So if this this energy generation phase of the black hole, so these quasars are so powerful that we can actually see them, even though they are billions of light years away, and they are by far the most energetic objects that we know, that we can observe in our space, in any kind of frequency, whether it is visible light or X-rays or gamma rays. Across the entire spectrum of electromagnetism, quasars emit very high energy. Now this particular neutron star is also emanating similar traits, not as big as a quasar, but very similar traits. So in a typical quasar, you will see these jets which will come out from the pole of the quasars, and the quasar in the middle shines brighter than the entire galaxy. So similarly, this particular binary object in our own galaxy is shining much more than the entire Milky Way. So if some alien race is watching and observing this binary object, the chances are they would actually see this Hercules X1 because it is emanating so much energy, it will appear brighter than the Milky Way. Now, for us to examine the Milky Way is rather tough because we are within it, and to examine things from within is rather tough. But somebody is from outside, if it is looking at the Milky Way, they will see Hercules X1 as a very, very extremely bright point, much brighter than the entire galaxy. So this is what this neutron star is emanating, and this is very surprising that, you know, for all these years we were we were examining it, but we did not know the exact nature of Hercules X1, which is similar to a quasar. And because of this the energy which Hercules X1 is throwing out, either from the core or from the gas explosion which is happening, it is actually affecting the surrounding areas. So the cycle of formation, cycle of destruction is going on around this neutron star, pretty much like what a quasar will do to the surrounding space. So friend, this is very interesting, and even a small object can take something like become something like quasar is very surprising, and this is something new. So how many of these neutron stars that we have in our galaxy or any other galaxy, how many of these neutron stars have the capability to eject so much material with so much energy? We are still learning. I think more study will be required, and as and when more study is done, and as and when they are published, I will actually come back to you and give you more information on these celestial objects. So friends, thanks for watching me live. If you have any questions, feel free to send in your comments and suggestions. And for today, I like to say goodbye, only to catch you again in the next edition of Akulmach Science. Until then, have a nice day. Bye bye for today.